Hi everyone, this is Mr. West. We're doing more dabbling into precalculus with the law of sines in this worksheet for Kuta. If you don't know about law of sines, you really need to have that a kind of foundational piece in place before taking on this worksheet. But just as a reminder, the law of sines is the sine of A over the A, and the sine of B over B is equal to the sine of C over C, okay? A, B, C. I didn't say it in the correct order, but you get my meaning. That's the law of sines. And it's really helpful for finding the angles and sides of a triangle. So you can find all those sides given by the little letters and the angles given by the big letters, okay? It's asking in 1 through 4, state the number of possible triangles that can be found using the given measurements. Now let's talk about something real quick before we get into that. We'll talk about how there can be more than one triangle given the measurements. The main principle behind this is if you have the coordinate plane here in precalculus, you do this a lot with the unit circle, but if we can draw a triangle in two different ways, okay, and have it have essentially the same measurement, okay, A and A prime, basically the same measurement. But in terms of using sine, cosine, tangent, the trig functions, these are two different angles. You have this angle, I'm going to draw it in this light blue color. We have this angle right here. That's an angle, and then this is technically the angle that's formed there. Now, one thing you'll see as these are supplements to each other, okay? 1 plus this other one will equal 180, because then you'd have, it wouldn't be that angle, it would be this right here. And if you add those two together, this one and that one, you'd get 180. So it's supplements. That's something to keep in mind. The other thing about this, so there's two different, that's what I mean by you can have two different triangles, okay, with the same sign. So the sine, for example, the sine of, just as an example, sine of 30 equals 1/2, and then the sine of 150 is also equal to 1/2, or 0.5. So that's, notice how 30 and 50, 150 are supplements. Okay, so that's all I was saying when I was talking about that. Okay, the next thing, if there is no triangle, you'll try to take the inverse sine of something to find the missing angle, and there's going to be an error on your calculator. So that's a way there's no triangle. This is like my breakdown. It's a simplified version. There's a much more extensive version, but I'm just trying to simplify it for you. If there's one triangle, that means there's no valid supplements. I'll get what that means in a second. And if there's two possible triangles, that means there's a valid supplement, okay? Now, up here, 30 and 150, those are valid supplements. For example, if one of the angles was 30, and actually, no, I'm going to get into an example. I don't want to get into it right now. I'll get into an example. So let's go ahead and start with number 1. State the number of possible triangles that can be formed. The first thing you're always going to want to do is you're going to want to, sorry, I have I'm not using my best calculator here, so you have to bear with me. The first thing I always like to do is I like to draw the triangle. So I'm going to draw the triangle here, and it doesn't matter what it looks like. Okay, I'm just going to try to get it into the frame. And then I'm going to label A, B, and C. Make sure you label it in order. Okay, so then we have A, we have B, and then we have C here. They always need to be opposites. Okay, B, B, C, C. Okay, you get it. Now we're going to change, A is 31 degrees, so I'm going to change my colors here. Let's call this 31. A is 16, so I can get rid of that. A there, and then C is 20. Okay, and it's asking to see the number of possible triangles. So what are we going to do? Well, we're going to start by using the law of sines. The law of sines, the best way I like to think of it, is you can circle an angle in its opposite side, okay, and another angle in its opposite side, and you only have one missing piece of information. In this case, it's true. We only have one piece of missing information, and that's angle C. So we're good. We can use the law of sines here. Let's go ahead and put the law of sines onto paper. So let's start with A. That's our known. So we can say sine of A over A equals sine of C over C. I always like doing that. I'm not going to do that again just because we're going to save time by doing this. Sine of 31 over 16. That's what A is equal to. And big A, the angle, is equal to sine of C. That's the unknown we're looking for. So I'm going to highlight it. Over 20. Notice how there's only one unknown here, which is good. You only can have one unknown. So we're going to cross multiply here. Let's use a different color. Sticks out a little bit more. Purple. And we get 16. I'm going to leave it like this until I'm all done. Sine of C, sorry. Okay, again, there's our unknown. And that's equal to 20 times sine of 31. So now what I'm going to do is I'm going to divide both sides by 16. Okay, so now I'm going to go ahead and type this on my calculator. I have sine of 31, and I don't have a graphing calculator, so I'm just doing sine 31 times 20. Oops, sorry. Again, I don't have my graphing calculator with me. Times 20. Okay, so I get 10.3 about, and then I still have to divide that by 16. Okay, so then I have that, I'm going to go ahead and just use this base. I'm not going to do number 3, or I'm just going to go over here. Okay, so then we have sine of C is equal to 0.6437, etc. I'm going to take the inverse sine now of both sides. That's how you get the C by itself. Okay, so then I'm going to take the inverse sine. So C equals the inverse sine of the above, 0.6437. And I'm actually going to include a little bit more digits when I do that inverse sine. So inverse sine, on the Google calculator it calls it arc sine. So it's 0.64379759. Okay, so I'm going a couple digits here. And I get 40. I get C equals 40.07. Okay, so now I have my missing angle. Now here's the thing. Remember how we said it's possible it could have a supplement? Because remember, 40 and its supplement both have the same sign. The sign is equal for both those measurements. Sine of 30 and its supplement both have the same value, because in the first and second quadrant, the y values are positive, and that's where that comes from. Okay, so this potentially could be 40.7 or 07, sorry. 40.07, but it could also, we're going to subtract that from 180. It could also be or 139.92. Or actually, we'll call that 93. Okay, so these are our two possible values of C, because the sine is going to be the same for any angle and its supplement, so we always have to check those two values. Now, here's the thing. This is what I was talking about with valid supplement, no valid supplement for one triangle, okay? So what we need to do here is we need to add 40 plus 30, and is that less than 180? It is. It's about 70. So technically those could work, because we can't have a triangle that has an angle sum of over 180. Then we also need to add 139 and 31. Is that less than 180? Well, it's about 140 plus 30, that's 170. That's still less than 180. So there's two triangles potentially that it could be. Angle B could either be 10 degrees or it could be about 110 degrees, depending, okay? It's not asking for the angle measurements, but it's saying that even with these two possibilities, there's still two valid possibilities with angle B. Like I said here, there's a valid supplement available. Okay, so, or I should say, with the supplement, there's another valid angle. It's a valid triangle. I like just saying valid supplement. So this one is going to be two triangles. Okay, so there's two triangles for number 1. Okay, now let's go do another one. I mean, a lot of these problems are pretty long, so this is probably going to have to be a 2-part video. So let's go ahead and make sure we get to a few problems. I also forgot to mention, this was a video by request. Scotty commented and said he wanted this video, so thank you for requesting this video. Sorry, it's taken me a little bit to get to it. All right, so let's go ahead and just do number 2. Shoot, my calculator disappeared. Number 2. Let me go ahead and I'm going to draw it first, just as like I said before. Okay, give me a moment. Sorry, just getting my calculator calibrated here. There. Okay. All right, so I'm going to draw the shape first. Okay, there's my shape. I'm actually going to do number 4 instead, just because there's a little bit more room for number 4. I'm going to put my triangle here, and I'm going to call this one A, B, C. So that means this is 64, C opposite 33, and 32. So they gave us a similar case for number 4. Okay, so with number 4, what we're going to do here is we're going to go ahead and see if we can get the law of sines cooking here. We have an angle on its opposite side, and then we have only one missing value, and that's C. So we're looking for C here. So we can say sine of C over 33 is equal to sine of 64 over 32. And this is where we get into the math, where we cross multiply. So we have 32, okay, 32 sine C equals 33 sine 64. I'm going to divide by 32, and eventually I'm going to take the inverse sine. So first I'm going to solve all that in my calculator, my crappy calculator. So we have 33 sine 64. Okay, that should be, okay, gives me an answer, and then I'm going to divide that by 32. Okay, and I get 0.92. So I need to take the inverse sine of 0.92, and I should get C by itself. So inverse sine of 0.92, I'm going to do a couple digits here. You really want to, if you can, just keep it stored on your calculator, because you don't want to just do tenths or hundredths. You're going to want to be as accurate as possible. So when I get this, I get 67.95. That's angle C. And as we said before, its supplement is also valid. So we got to check it. I shouldn't say also valid. I should say its supplement also has the same value for sine. So I know that's going to, we can subtract this from 180. And that's also going to be a possible angle. So 112.05. Okay, so these are our two possible values for angle C. Now, what we do is we add both of these to the existing angle, 64. Let me change color here. 64, so 67 plus 64 is less than 180, so it's valid. Okay, 112 plus 64. 112 plus 64. And we're actually still less than 180, so that would be two triangles again. So two triangles again, because both those angles can work with angle 64. Okay, I think it's 3. I really want to finish this off and show you what it looks like. So page 1 will probably be its own set of questions, and then I'll do page 2 in a part 2 video. Okay, but I really want to show this. So let's go ahead and try to do this a little bit more quickly. We'll call this B, C, and then we'll call that A. So this is 110. This is 11, and then A is 4. Okay, so we already have a relationship. I circle here. The only one we're missing is A. So we can set up that the sine of A over 4 is equal to sine of 110 over 11. So I'm going to do sine of 110 times 4. I'm cross multiplying here. And then I'm going to divide that by 11. And I get 0.34. Okay, I have to take the inverse sine of that to solve for A. So A equals the inverse sine of 0.341706407. Okay, and I get 19.98, so about 20. This one's, okay, so it's supplement. This is a good one, okay? So then it's supplement, okay, if I subtract this from 180, is 160. About, okay, we're just rounding here. So here we have a 19-degree angle, about a 20-degree angle, and about a 160-degree angle. Now, clearly, if we add 110 plus 20, that's less than 180. But what happens if we do 110 plus 160? It's well over 180, so it can't be that angle. It can only be this angle, so that means there's only one triangle that can be formed here. That's what one triangle looks like. Okay, and then this one actually is no triangle, and what happens there is you're going to have sine of, what's it trying to find? Sine, you're going to have sine of A equals when you get done with the math, is going to be equal to something like 1.7 or something, and something above 1. And when you take the inverse sine of that, it's going to say error. Anytime you get that error message when you're trying to find the angle, that means there's no triangle. Okay, there's no triangle that can be formed because it doesn't make a complete triangle. So that's like the basics of, can you make a triangle with the measurements given? Okay, now let's get into this right here. Find each measurement indicated. Some of these are multiple options. Okay, so this one's trying to find a side. There might be 2 side lengths. This one's trying to find a side. There might be 2 side lengths. Some of them are trying to find angles, maybe. This one's trying to find an angle. Okay, so we'll same principles apply. We're going to first see if there is a second triangle we can make. And it kind of stinks because we're going to have a lot of work ahead of us if there are more than one triangle, okay? So let's go ahead with the first thing we're going to do. I'm going to do number 6, and then I'm going to actually probably skip down to one of these angles, and then maybe I'll do one of these, and then we'll call it a video, and we'll work on a part 2 afterwards, okay? So here's, and this is going to be one I'd highly recommend looking up the answers for, just so you can check your work. All these Kuta worksheets, you can do that. They're pretty easily found. So here we go. Let's call this A, B, C. We know A is 57, C is 35, A is 33. Is this the same measurements as it was earlier? No. Okay, here we go. So, again, we're going to circle our values here. So we have this, opposite side, only one missing value right here, angle C. So we know that the sine of C, I'm going to use blue and just leave the C by itself. Sine of C, okay, and this is the same process we've been doing before, over 35 equals sine 57 over 33. Cross multiply. Okay, I'm just going to leave it the same color. So I have sine 57, I'm going to type that in my calculator, sine 57 times 35, cross multiplying. Okay, and I'm going to divide. I'm going to go ahead. I know I'm going to divide by 33. If you guys follow that, I think you guys, if you're in this pre-calc class, you guys are probably pretty good. Okay, so we have sine C equals about I'm just rounding here, 889. I'm going to type in more values than that, though. Okay, so I'm taking the inverse sine of that, 0.889, 49908. Okay. So I get C equals 62.81. Highlight. That's one possibility. Remember, its supplement also has the same value for sine. So it also could be 117.18. Now, this is where you decide, can you have 1 or 2 triangles? If it's 1 triangle, you're in luck. If it's 2 triangles, you're kind of out of luck. It's just not out of luck, but it's just a little bit more work. So what I'm doing here is I'm saying, okay, can I add 62 plus 57 be less than 180? Yes, so it makes a valid triangle. What about 117 plus 57? Does that add up to less than 180? And yes, the answer is yes. So there's 2 triangles for number 6. Okay, now, if it is only 1 triangle, then you just go from there and you solve for the missing value. And it's usually pretty easy. You could start with the angle. So, like, for example, if I knew it was only 1, this one didn't work. It does, but I'm just doing an example. This would be 62, okay? And then I would find angle B, and I would subtract that from 180. So what is that? That's 110, 119. That'd be 61. So it'd be 61. And then from there, I would set up another sign and then solve for the missing side there. Okay, that's how I would do this if there was 1 triangle. There's 2 triangles, so it's a little bit more complicated. I'm going to talk about that. And the best case scenario in terms of speed is no triangle. So if it's no triangle, you're going to take the inverse sine here, and you're going to get an error, and that would be no triangle. Okay, just so you know. And that's for all of these. All of these ones on this page, it's the same deal. I'm actually doing the hardest case, which is two possible triangles. Okay, so now I know it's not just 62. I'm going to erase this, clean this up. It could be 62.81 degrees, or it could be, let's use purple actually, 117.18. 117.18. Now, this is where I use the angle sum theorem. So I'm going to say 117.18 plus 57, that's my other angle, and that gives me 174.18, 174.18, and I subtract that from 180 to get my other angle, 5.82. And you're going to want to round these angles, okay? I mean, you're not going to want to round to the nearest whole number. You're going to want decimal places. The more decimal places you include, the more likely you are to have accurate results versus inaccurate results. Okay, I have to do the same thing for the 62.81, so 62.81. Okay, I typed it wrong, 62.81 plus 57. And then I'm going to subtract that from 180, and I get 60.19. And that's what I just said earlier, okay? So I have two possible angles that I'm going to have to use. Now, here's my suggestion. No matter what you're doing, okay, always use the one that doesn't have the decimals as one of your first law of sines proportions. So I'm going to say sine of 57 over 33. And I'm going to set that equal to, and now I'm going to choose purple first. I'm going to go sine 5.82 over my missing value. I'm asked to find b. That's my goal right here, over b. Okay, so then I have 1, and then I'm going to do the same thing just so you know. I got to set it up ahead of time. Sine 57 over 33, and then I'm going to do the same thing with the pink. So this is equal to sine of 60.19 over b. And again, I'm solving for b and those because there's two different possibilities. Okay, so now let's go ahead and do this. I'm going to do this for the purple first. Okay, I'm not writing out all the steps. I'm typing on my calculator though, which I think you should do as well. So I'm going to do 33 sine of 5.82. Okay, and then I'm going to divide this by the sine. Okay, this one's a little bit different, so I'm going to show. So I get 3.34 equals b times sine 57. So now I'm just dividing by sine 57 to both sides. Okay, I didn't write out everything, but I did write out a little bit. Okay, so I'm dividing by sine of 57. And that one's not even rounded, it's complete. That's how it was originally. Okay, so I got b equals 3.99. Okay, so that's about 4. I'm guessing it wants us to round to the nearest tenth, so that is 4. And what are the units? Centimeters. So that's one of our answers. Okay, if this was one triangle, I would be done. But it's not. I have a second triangle here. Okay, so I have to cross multiply again. And then I have sine 60.19, sorry, rather. Sine 60.19 times 33. Okay, so that's 28.63-ish. And then I have b times sine 57, which I divide by sine 57 again. You do it the same way both times. That's like kind of the redeeming grace of this, is that at least it's similar for both of these triangles. And I get b equals 34 nearest tenth, 1 centimeter. Okay, so there's my answers. And that's how you do all of these. Okay, I think I'm going to do an angle one for you too. I'm probably running out of time for this video. So maybe I'll do an angle one real fast. Okay, so here's my, obviously I'm speeding up here. So KHP. I have to label exactly how I see it, KHP. So I'm given that this is 55 degrees. P is 18 centimeters, opposite P, and then the K is 27. All right, I'm asked to find the measure of P right here. Actually, this shouldn't be too bad. The first problem I did was actually much tougher. So I have these two proportions here. I have sine 50. I don't know why I keep forgetting that I. Sine 55 over 27 equals sine of P over 18. So I'm going to do 18. I'm cross multiplying here. 18 times sine 55. Okay, I get 14, and then I'm going to divide by 27. This is kind of what we did in the beginning, and I get sine of P equals 0.546, and then I need to take the inverse sine of that. Okay, include as many digits as you can, so 0.546 oops, 546, 10136. I'm going a lot here just to be as accurate as possible, and I get angle P equals 33.099er. Okay. Now, so that's 33. Now, I also need to calculate what? Its supplement. So I have to do minus from 180, and the other possible angle with that same sine value is 146.9. Now, can I add 146.9 with 55 and 33 plus 55 to have it be less than 180? This plus this is definitely less than 180. That's valid. 146 plus 55 does not work. Okay, so you're always checking this first. Can't use 146 then, so this is our angle, and that is good. We're good to go. Only one angle there. I think these ones, 13 and 14, are a little bit easier. It's asking to solve the triangle, so basically what we're going to do here is, well, this one's easier. Most of these values, I think there's only one value. I don't think there's multiple values for this one, which makes it easier. So now we just do 180 minus 113 minus 36, and we start with the angles, 31. So now we have all the angles, and it's just cake from here. Honestly, it's pretty easy. This is like more like a 10th grade geometry versus pre-calc problem. So now I have these two values. Like I could call that x and call that y, and I'll start with sine of 31 over 14. That's going to be my go-to proportion, is equal to sine 36 over x. Okay, and then I'm just going to type in sine 36 times 14, times 14, and I'm going to divide that by sine of 31 divided by sine of 31, and I get x equals 15.977. I'm not sure what the rounding is. Rounding error to the nearest tenth. Okay, so that's 16. So 16 yards for that one. Okay, and then for y, I do the same thing. I'm going to use the same proportion. Don't make it complicated yourself and try to use the new one you just found. Don't be fancy. Just do what works. 113 over y this time. Another side length. Okay, I'm going to cross multiply again here. So I have this time sine of 113 times 14. And then I'm going to divide by sine of 31. And I get y equals 25. 25 nearest. So that is 25 and 16 are my values for the other triangle, 31. So that's how you do solving for the triangles. Okay. I'll get back to you in another video. This part 1 was probably too long, but part 2 should be a little bit quicker. I'm going to do a couple of these and then find the area with that last one. Stay tuned. Hope to see you soon.